Hey guys, so today we're going to be looking at a quick review of right angle trigonometry or right angle triangle trigonometry, and hopefully this is revision for us, why it's called a review, but we'll go through it I guess as slowly as we can. The first thing that we want to make sure that we remember is SOH CAH TOA. Okay, this is the trick to remembering our trigonometric ratios, which is helpful because remembering those is how we do our right angle trig real quickly. So the three ratios that we're going to be talking about is sine, cosine, and tangent. Okay, so the sine of an angle is its opposite side to the angle, by the way, the opposite side to the angle, which we'll talk about in a second in the diagram, divided by the ratio. So the ratio of divided by the hypotenuse. So the opposite to the hypotenuse. Now, you have cosine, which is the ratio of the adjacent to the hypotenuse, and tangent, which is the ratio of opposite to adjacent. Be careful because this does only work for right angle triangles, so you want to make sure that you see the 90-degree angle or that you can demonstrate that it is 90 degrees at some stage. So, with the angle, the opposite and the adjacent sides might change. Alright, so you need to pay attention where the angle that you're interested or that you're going to use is, because that changes where the opposite and adjacent is. The hypotenuse, however, stays the same regardless. It is always opposite to that 90-degree angle, and it is the longest side. So you want to consider the hypotenuse first, because you don't want to confuse it with the adjacent a little bit later, because that hypotenuse is also adjacent to this angle, but it's the hypotenuse, not the adjacent side, which is the other one. You have the opposite, the one furthest away from the angle, and then the adjacent, which is the one next to it. Hence the word adjacent. So, that's frustrating. Mouse cursor in the way. Real quick, if you had a right angle triangle with a 30-degree angle, then the ratio of the opposite sides of the hypotenuse is 0.5, okay? Or you could say that sine of 30 is 0.5. Remember that sine is the ratio of opposite to hypotenuse. So the ratio of opposite to hypotenuse when this angle is 30 degrees is 0.5, and that's one of the values that we're going to need to remember off by heart a little bit later down the track. But for now, I'm just going to use it as our example. Okay. So if that angle changes, so does that ratio between them. With our right angle trig, we are trying to connect three bits of information and only one unknown. Okay, I need to make sure there's an n in there. If you have 2 out of 3 bits, one unknown, then you should be able to rearrange and solve the problem. Let's do a quick example. Alright. We have a 90-degree angle triangle, which is why our SOH CAH TOA works. Alright. Decide which ratio to use first. So which one's going to connect the bits of information that we know, and one bit of information that we would like to find out. So you need to decide which sides are being used. This is the side that is furthest from the angle, so this is the opposite. We have the side opposite that 90-degree angle, so we have the hypotenuse. And obviously we've got this angle, which is our third bit of information. OH is SOH, so we're using sine. Sine of 40 degrees is equal to opposite over hypotenuse. And then you just need to quickly rearrange. So multiplying both sides by 25, and you get x by itself. Go to your calculator, which might get a lot of glare off of. Hopefully that helps. So we're going to do 25 times by the sine of 40 equals. Now, if you're not getting this answer, if you're trying it yourself on your calculator, you want to make sure that your calculator is set to degrees. Occasionally, if you haven't changed it, or it might accidentally have been changed, reset, it might be in radians to begin with, which we'll learn to use a little bit later. So we have definitely set in degrees, which is good for me. So we get 16.07. Don't forget about your units, which is in centimeters, because that's what we start with here. Occasionally you might be asked to find what is inside of your sine or cosine tangent function. What are your trig functions? Okay, so you're going to need to use the inverse. Sine to the -1, cos to the -1, tan to the -1. There are other names, but I forget them, to be honest. Alright, so it might look like this situation. We've got sine of something that we're trying to find out is equal to some ratio or value. Quick tidbit, sine and cosine should always be between 0 and 1, or we'll talk about negatives in a later case, but usually between 0 and 1. Okay, if it's not, then you've done something wrong, or it's not a triangle. Anyways, so we are looking at the inverses. You would use the inverse of the whole side. Okay, so everything on the opposite side of that sine function is now inside my inverse. Okay, you can think about this kind of like your square root or some other similar idea. Okay, you are doing the opposite of the square root for both sides, so everything that is on the other side is inside that brackets, making sure that what's the usual problem here? Anyways, last little bit that we need to get through, and then a couple of examples on it, is minutes and seconds. Okay, minutes and seconds, just like time, hours, minutes, seconds. Degrees can be expressed in a similar fashion. So you have minutes and seconds when it comes to degrees, where 1 minute is 1/60th of a degree, and 1 second is 1/60th of a minute, or 1/3600th of a degree. So you can convert between minutes, which is expressed with a comma, which I've tried to show up here. All right, not comma, apostrophe. So 45 degrees and 15 minutes is equal to 45 plus 15 out of 60, because remember each minute is 1/60th of a degree, and that's where you get the decimal from. Alright, but the calculator can be a great help for you. Alright, so you might find this. This is the button on my calculator. It's got degrees, apostrophe, and then double apostrophe, quotation. Other calculators have different ways to do it. You might see the letters D, M, and S. The TI, you would find it in this section over here where the pi is. Okay, there's degrees, there's minutes. So there's different calculators work differently, look it up, check the manual, ask me if you can, and we'll see if we can figure it out for you. So let's try and use that in a couple of examples. So you can use the degrees and minutes if you can type it into your calculator instead of converting it to a decimal first, which is what we'll try and do. So the first example is we're trying to find the value of x. First thing we need to do, what ratio are we going to be using? Well, opposite the 90-degree angle is our hypotenuse. Okay, and we've got the adjacent side, so we've got adjacent side. So we have to use AH, which is cosine. So cosine of 31 degrees and 15 minutes is equal to x over 12.7. Rearrange, we're going to get x is equal to 12.7 times by cos of 31 degrees, 15 minutes. Okay, again, calculator's fading a little bit. 12.7 times by cos of 31 degrees, 15 minutes, bracket, making sure that my calculator is in degrees. 10.86 is what we should get. 10.86 centimeters. If you have a expression of an angle, you can use the same button on your scientific calculator. It's a little bit different on your TIs or your class pads. So I recommend using a scientific calculator for these things. It's a little bit easier, but I'll try and show you in a moment, depending how much time we've got. Low battery. Evaluate theta to the nearest minute. So again, what ratio do I need? I've got hypotenuse is this one, so this has to be the adjacent. Furthest side is my opposite. Opposite adjacent gives me tan of the angle that I'm trying to find is opposite 6.8 over 7.4. Yeah. Occasionally those units for your length might not be the same, so double check that that's the case. They're both in centimeters, so we're good here. I will need to do the inverse, tan to the -1 of 6.8 over 7.4. I've done the inverse of both sides, so tan disappears on the left. Alright, let's see if this works. We've got tan to the -1. You might need to use the shift button so you work it out, and we've got 6.8 divided by 7.4. Close bracket equals, that gives me a decimal. Alright, if I hit the degrees, minute, second button, then it converts it to degrees, minutes, seconds. Fancy that. So I have theta is 42 minutes. This is to the nearest minute. Okay. 49 seconds is pretty close to the full 60, so we're going to be rounding up here, making it 35 minutes. Last thing, if you were doing it on the TI, which I would use the program here instead of the actual TI, we can say something like tan to the -1 of 6.8 divided by 7.4 equals, and you might need to use this book section. It is in section number 2. Alright, we would need to open up the angle thing if it's your first time going into it. Scroll down, convert to DMS, degrees, minutes, seconds, enter, and it's the same situation that I've got there. Alright, I hope that helps you out. Let me know if you've got any questions, and we'll see you next time.